Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem ID 2140, solving questions with Brainpower. This problem is based on dynamic programming and it's a Amazon interview question marked as medium. Let's have a look on the problem statement. Here you are given a zero index integer 2D array questions where every entry in the questions is having first value as points, second value as Brainpower. The array describes the question of an exam where you have to process the questions in order. We have to process all the questions starting from the first question to the end question in that particular order and make a decision whether you have to solve it or skip it. We have only two options, and solving question I will earn you points I. But you will be unable to solve each of the next Brainpower I questions. If you solve this question, you will get 3 points, but you will not be able to solve next 2 questions because Brainpower is 2. And if you skip it, just skip it and make a decision on the next question. And this is just an example. For example, given question is like this, and if a question is 0 is solved, you will earn 3 points. But you will be unable to solve the question 1 and 2 because those are next 2 questions we can't solve because the Brainpower was 2 for the first question. Instead, question 0 is skipped, then just make a decision on question 1 and do the same thing. Ultimately, what we have to return is maximum points you can earn for that exam. So it's a maximization problem where given part is questions array, and in that questions array every question is having 2 values, points and Brainpower. If we want to earn the current points from the current question, just solve it and get the points and just skip the next Brainpower high questions. In this case, if I just try to pick 1, it means I have to skip 2 and then I can pick 3 and then I have to skip next 3 questions. So points I will be getting is 4 in this case. But if I just skip first and choose 2, I will be getting 2 points from this and I won't be able to solve next 2 questions and I can solve this question. So 5 plus 2, 7. And from the above arrangement, we am getting 4. So 7 is the maximum score. So in this way, we have to do the maximization over the score and we have to solve the questions accordingly. So this is our problem statement and let's see how we can solve it. Let's say we have solved the 0th question. See, that is also sure that we have to start from 0 and till the end of the question because we have to solve it in a specific order. We can't change the order. Our first question is question 0. I have 2 decision over this. Either I have to solve it or I don't have to solve it. If let's say I have solved this question, if I solve this question, I will get 1 as a point. Plus, I have to skip 1 question and after that I can solve further questions. So in this case, I can have 3,3, 4,4, 5,5. If I choose it like if I solve the first question, then I have to get further score from these 3 questions. If I just skip it, I have to get further score from these 3 plus the second as well. Copy, paste. Now I will include 2,2 as well. So in this case, you have to get score from these 4 questions. If you just solve the first question, what is the remaining problem? The remaining problem is you are given this array and you have to get the maximum score so that if you are picking the current question and solve it, you will get points I score. But Brainpower I we have to skip. See, this is the same problem. This is the problem. If I just mark this problem as capital P, our biggest problem, then in this case this is the sub problem and this is also subproblem. Subproblem where we don't have the first question, subproblem where we don't have the first two questions. So this biggest problem is leading to two subproblems of the same nature. Problem and subproblem is of the same nature, then we definitely have to use recursion. So in the interview, if you are going to use recursion, then it would be great if you are able to give the small justification for that. Okay, so this is the problem statement now, and this is the problem statement now. In this case, you have to start solving the question from index 2. In this case, you have to start solving the question from index 1. Why? Because we are just skipping 0. In this case, we are considering 1 and we are skipping 1 questions after that. So my score will be 1 question, I have captured it, and so on. Okay, so ultimately what we have to do is, see, what the problem is expecting is start solving questions from index 0 onwards and just get the maximum score. Start solving questions from index 0 and get the maximum score. It means they are expecting us to write some kind of recursion function where we have to start solving questions from index idx, and our first call is going to be 0, solution of 0. Let me just show you this call. Solution 0 is going to be my first call, and in the first call I am getting 1 score, and then score is 1 plus solution of index was 0, next index is 0 plus 1, but we have to skip some indices as well, that is 1. Okay, see, if we are not skipping any index, then from 0 I am going to 1, but I have to skip this as well. So from 0 to 1 I will also go, but I have to skip this as well. So this 1 will be added to the index, further index. So 0 plus 1 plus 1. If I just take the first question, take the 0th question. If I just don't take the 0th question, then whatever will be the answer of solution 1, that is going to be my answer. So in this case, if I just simplify it, it is like solution of 2. For solution 2, we have two possibilities. This is my question 2. Either if I take 3 point, or I just move to 3 plus 1 plus 2. So for solution 2, I am taking points from index 3, that is 3, plus solution of 3 plus 3, that is 6. See, in this case 6 index is out of this quotient bound. In this quotient we have indices from 0, 1, 2, 3, 4. After 4 there is no index present. So in that case, if there is no quotient, there is no score. It means that we have found our edge case. If the index is greater than or equal to n is the number of questions, in that case we can directly return 0, that we won't be able to get any score. But if we skip the solution 2, my solution will be solution 3. Solution 3 I have to get, and in this case solution 1, the same thing I'm going to use. So if I just try to write the recursion here, my recursion will something look like this: solution of idx, where my first call is going to be solution of 0, right? And I'm going to return long, because the points range will go till 10 to the power 5. Okay, so this is my function. First of all, what was our edge case? If there is no question left, it means if idx is greater than or equal to n, in this case return 0 directly. Now we have two possibilities. First possibility, let's say first possibility is I'm able to capture score A, that is solve the idx question. If I solve the idx question, whatever like question idx 0, question idx 0 is the Let me make it very simple. See, we have the quotient now. It means the quotient index is valid. Now we have point I is equal to quotients of idx at index 0. Now what is brain power? Brain power is idx quotient, first value is the brain power. Now we will definitely have these two values because the index is valid. And now what are the two possibilities? First possibility is whether I am picking or solving the current question. If I solve the current question, what is the score from the current question? Point size the score from the current question plus solution of idx plus 1 if we are not skipping anything. But if we are skipping something, then point index plus 1 plus bi. See, this is the first sub goal I'm going to make. And what is the second possibility? Second possibility, let's say b is the second possibility. In this case, I'm just skipping the current question. So in this case, idx plus 1 will be giving me the answer. So these are the two subsequent calls I am making. Index plus 1 plus bi. Second one is index plus 1 because I am just skipping it. So among these two values a and b, whatever is the maximum I can return, because at every step we are making two decisions, and for n values we are making 2 to the power n decisions. So return this value. So this is going to be my my recursive code for this approach, right? This is my recursive code. Here if I just try to finish up this recursion by just taking it. So what I did in this recursive quotient, I hope you are able to understand this one. So this is my edge case, and these are my sub problems, and from those sub problems whatever is the maximum value I'm getting, I'm returning that. So this is just pretty straightforward, like house robber problem, which is standard DP problem. Okay, from 0 to 2, for 6, for 3, 6, this call is over, and for 3 we have two options. Let me take the array as well. 0, 1, 2, 3. At index 3 we have two possibilities. Just take the value at index 3, that is 4 plus 3 plus 1, 4 plus 4, 8. Go to index 8. This is like terminating case, and this is going to give me score 0. So ultimately from this call I'm getting score which is equal to 4. And now if I just skip the 3, then I will just come to index 4. Solution of index 4, and the solution of index 4, I have two possibility. 5 plus solution going out of bound, so 0. And if I just skip it, then again I'm going to be getting 0. So in this case my score is 5, and in this case the score is 0. In this case the score is 4. Here the score is 3. And now if I just come to solution 1, if I just solve it, I will be getting 2 points and 2 items we have to skip, 2 quotients. So 2 plus solution of 2 plus 2, 4. 1 plus 1, 2. And 1 plus 1 is 2, but we have to skip 2 items as well. So 3, 4. So I will be coming to index 4. Solution 4. See, solution 4 is something I have already captured in advance, right? When I was just doing the recursion tree, it was something like this, coming here like this, and then when I'm coming to solution 4, I'm encountering the same problem that I have already solved. So this subtree I have already solved, and I am not going to solve it again. So if I am not going to solve it again, then you can save your time by doing the memorization, right? If you are not doing the memorization, every step, every index, we are making two decisions: just take it or do not take it. And we are having two decisions at every step, and we are having n step, which is 5 in this case. So time complexity will be 2 raised power n if we are doing it right, like the way we have wrote our recursion. If you want to save it, we can try to analyze the subcall and what are the different subcalls I can make. My recursion function is this, and I am getting a parameter which is index. What can be the value of this index? This index value can go from 0 to n. 0 to anything, it can go anything. But here, if it is going from 0 to n minus 1, I might have to do the processing. But for any subsequent index values, I will directly be returning 0. So after this base case, I am trying to process the index, and I will be processing it if it is a valid index from 0 to n minus 1. So all of these valid. So for all of these valid indices, I am doing the processing, and ultimately I'm just returning the answer for that particular index. So solution IDX is my call, and at max I can have these many calls: solution of 0, solution of 1, solution of 2, solution of n minus 1. For solution of n plus 2, no, our base case is comfortable to handle this situation in order of one time. There is no processing required. So for all of these values, I require some processing, and if these values are in a specific order, if I just take an array of size n, indices values are going from 0 to n minus 1, I can utilize this array as my cache to store the result from all of these subcalls. So for solution of IDX, call will be stored at dp of IDX, and IDX value will go from 0 to n minus 1. If it is in this case, I am going to store it. I'm going to store it in this array, and in this array I can take of size long. So whenever I'm starting my processing, so before the starting of the pre-processing, just check in the cache. If it is not present in the cache, just do the processing and store it before returning. Right? In this way, we have reduced the number of calls from 2 raised power n to only n. And the final time complexity will be order of n in this case. But about the space complexity, we are also using some extra space to store the call result from the call. So this is our top-down DP, or you can say recursion with memorization. Now let's code this approach. Here, first of all, I have to write a recursive function which is going to solve the problem. See, we have to capture the maximum score starting from the index 0 in the quotients. It means starting from the quotient 0, we have to get the maximum points we can earn by solving couple of quotients. See, solution 0 will give me the answer. That's if I start from the index 0 in the quotients, what is the maximum score I can get? Because my subsequent problems will be something like solution of maybe starting from index 2. And this is going to give me the answer. And okay, let me just write this function: private long solution int IDX. Starting from this index quotient, what is the maximum score I can get? Just to keep the parameters clean, I am taking this quotient array, quotient's value globally, and this int, and this is the length of this quotients. This dot q is the quotients, and this dot n is equal to q dot length. Now I just have to implement this function. Here we decided that our edge case will be if the index will go out of the bound. greater than equal to n. If we don't have any quotient, we can't get any point. Otherwise, I am at a valid quotient where the valid quotient is having points and the brain power. So let's capture the points. What is points? For every quotient at this index, 0th value will give me the point. And what is brain power? For this specific quotient at this index, value 1 will be the brain power. Now we have points in the brain power, and we will be having or making a decision to solving it or not solving it. If I solve it, I might get some points, but I have to skip brain power number of quotients starting from index I plus 1. So if you are not skipping any quotient, then we will definitely be moving to the next quotient. But in this case, just skip this number of quotients. What is the second possibility? If I don't do anything at the index idx wala quotient, it means just move to the next index idx plus 1. So these are the two cases. And what is the maximum value I can get among these two sub problems? What is the biggest problem? Starting from index 0, what the maximum score I can get? And these are the top two sub problems after P. So whatever the maximum value among these two, that will be my answer. And each of these two sub problems will have two sub problems subsequently. If I just run it over sample test cases are passed, and let's try to submit it, but it might give us TLE because the time complexity here in this case is 2 raised power n. For 2 raised power n, definitely we'll be getting TLE. In that case, we have to memorize our calls, and for that, taking a DP array of long value, I'm taking a long wrapper so that I can utilize null as well. What should be the size of this DP? New long of size n. Why? Because our processing is only at the valid values of indices. That's why I'm taking it a linear array. Before the processing, check in cache. If it is available in cache, just return from cache. And before returning, just store in cache. And my cache is this DP of idx, and I am storing before returning. And before processing, I can directly check if DP of idx is not equal to null, it means it is present in the cache, then just directly return it from cache. So checking the cache, storing the cache, this is called memorization. This is not that difficult like recursion. So yeah, recursion is the main part of our function. So now it is a recursion plus memorization problem, and let's submit it again. Sample test cases should pass if I am not done any compilation error. Sample test cases are passed. I'm submitting the problem again now. Now this is submitted successfully. I hope you understood the approach, and this question was based out on standard dynamic programming approach, taking any element or not taking any element and going sequentially. In case you get any doubt, you can comment down below or you can discuss in the Discord community. Thank you guys. Bye bye.